So our research has shown that the temperatures in the Southwestern Pacific, especially in the Fijian archipelago, were the warmest over the last 653 years. And with the temperature sensor, we mean that these corals record in their skeleton the chemical composition of the seawater, which is related to changes in temperature, how salty it was, how much it rained over the oceans. And we can reconstruct that by certain chemical tracers that we measure in the skeleton. So it's literally a living sensor of chemical changes in the ocean, which we then can translate to physical changes like temperature and rainfall and so on. You see, so that's the Ashmore core from northwestern Australia, right? And we drilled that because it's right in the center of these big ocean currents. And the good thing about this, but so far in this particular coral in that X-ray, I haven't seen stress bands on this particular part. You know, any coral reefs are normally called the rainforests of the sea, simply because of the multitude of organisms that share the space. So like trees giving a home to lots of species, corals themselves and the associated organisms like sponges and others, they provide a home to many other living creatures. But especially these larger corals that we are using for our climate research, they are really important for coral reefs because they are really fertile, meaning they can produce a lot of, let's call them babies. So they can actually reseed the reef. And they have a very substantial role in keeping the ecosystems alive because they have a higher ability to produce offspring. And if we lose those giant corals, which is actually happening in the recent bleaching events, then we also lose the potential to reseed these reefs with new colonies.